I'm an Android developer, and I recently, as in like yesterday, joined a cool company called Snap Mobile. And today I'll be telling you about building SDKs the Kotlin way. So, disclaimer, this is a totally new talk, and I will figure out as we go along how I do this. So first of all, before we dive into like building SDKs, I want to talk about briefly what an SDK actually is. I had to look that definition up as well, and some websites say, all right, an SDK is basically you take some APIs, you smoothen out some rough edges, but most importantly, what you do is you provide tools for other developers to use those APIs to make their lives easier. This can like package APIs that give you data, for example, like REST APIs, but this can also be like an API, for example, that sets a text color or something in a custom view on Android. So building SDKs is hard. I learned this the hard way in a project I just dove into a couple of months ago, and I had never built an SDK like outside of a hackathon project before, and I was like, yeah, sure, let's do this, right? It can't be too different to like building normal applications, can it? Oh boy, I was wrong. So building SDKs is actually really hard because you have to think about the way you design APIs. First, you have to think about, all right, how am I going to approach this? Then you have to think about how does a good API actually look like? I mean, is this easy to use? Is this something you would want to use, you would be happy to use? Is it something which is straightforward to understand? The problem with SDKs is that they really often have this very specific use case and this very domain-specific topic. For example, take the Google Maps SDK. It has like this super complex stuff underneath which it has to kind of abstract so others can actually understand it without diving too deep into the topic. So this is a really, really hard task to do, like designing an API that is easy to use, writing code which is understandable, and then that's like only the side of exposing APIs. There's so much more to it. You're writing an SDK, you're building it, and obviously you want to write maintainable code. You want to write code that is testable, and that probably in 10 years can still be edited in some way and doesn't just like lay around like dead fish. So you have to think about architecture, you have to think about encapsulating your components in a way, you have to think about how you can make testing work, and you have to think about how you can make it work to change APIs. Like you might have some experimental APIs. If you've used Kotlin before, you probably know about Kotlin coroutines and that they were experimental for a while and then they graduated to stable. So in the process of that, there was a package name change, and there's just a lot to it that you actually have to think about before and that you have to manage. Then, of course, as in every project, but even more so in SDKs, when you're building like very encapsulated components, as you gain more users, the requirements actually change. Like, you will only figure out as you build the SDK what your users actually want and what your users actually need. You can like have foresight as much as you want, and you can like think that you know everything, but spoiler alert, you don't. And requirements change, so your code has to be really flexible in the internal way so that you can easily change it, and code has to be kind of stable to the outside so that when you're like releasing a new SDK version, not every API just like changes with every release and your developers and users actually get pissed off. So today, this talk is a very experimental thing. I will be talking about some common pitfalls when building SDKs, sprinkled in with some awesome Kotlin features and some of my shitty drawings done on a 20 euros drawing tablet. So we'll see how it plays out. Take this with a grain of salt, because this is all very, very anecdotal. So imagine this situation. You are the developer, and your project manager comes to you, and they're like, hey, could you like slowly ship the new SDK version so we can get this out? And you're like working on some stuff, you're like, okay, yeah, sure I can, because you know that you are about to change some APIs, you deprecated some stuff, but you're like, all right, we'll just release it. We'll think about that later on. So you go like this, yeah, you do a Gradle build, 10 hours later. This is a very good slide if you don't have enough content, by the way. So you run the Gradle build, at some point it's finished, and you're like, all right, what do we do about those deprecated APIs? You're thinking, all right, release notes, right? We have release notes because we're like agile and everything. So release notes, you write some stuff, and then you put on there experimental APIs. Those are subject to change. They will change. I can guarantee you, they're not final. Like, don't just rely on them blindly. We all know developers, right? Right? You know the outcome. So a week later, your project manager comes to you, is like, hey, could you ship the new version? Oh yeah, cool, here's the new version 1.2 or something. Release notes, your APIs have changed. And you're like, all right, they should get this, right? Yeah, you see where it's going. You hand the new version over, and Q to Friday, 9 p.m., your project manager is like, hey, that very important customer just called, and they have a build error, and they're like in USA time zone, so it's Friday, 9 p.m. for you. Yeah, they have the new SDK version. Nothing is working anymore. Could you just like fix that now, please? Because money. Well, all right. You go into your Slack, even though it's Friday evening, because you think, all right, maybe I made a mistake. And you ask, hey, have they read the release notes? All right, ask. No, they haven't. Wow, what a surprise, right? Which is the moment at which you think, hold up, could I have handled this differently? Could I have done more than putting it just into the release notes? And the good news is, with Kotlin you can, because Kotlin is awesome. So in Kotlin there are some cool annotations which I want to talk about, which are called add experimental and add deprecated. And those are just like two of some awesome Kotlin features, but they were helping me a lot when building SDKs. So imagine you have your experimental APIs, and you want to make sure that your SDK users actually get that they are experimental, and it's not just in the release notes, so you want to make sure that it kind of propagates throughout the code base, so that everybody who's working on the code using experimental APIs actually knows, all right, this is experimental. I should take care with this. I shouldn't take this for granted, not to change. So there's the add experimental annotation, and the source looks like this. It's actually fairly simple. I removed some comments. And as you see, it's called experimental, and it has one parameter, which is the level. By default, this is error, but you could also set it to warning, and we'll get to what that means in a second. The other thing which is here important to note is this is actually targeted at annotation classes. So it's an annotation for annotations, meaning that the usage looks like this. Using the experimental annotation means that you will define an annotation class. So say you have like this API which delivers cat pictures. And because you're a good developer, you know it might change. So you say, all right, everything which is experimental in that API, we will mark with add experimental cat pictures API. So there's a good reason for why we annotate an annotation. This allows scoping, which is very, very useful when you have multiple experimental features which you want to pull up to stable version by version and just not in parallel. So imagine you have this cat pictures API, which is really simple. And it just returns a cat picture, right? There's this method. And because you're foreseeing, you say, all right, cats might overtake the planet, and they demand pets and treats in exchange for cat pictures. So you might have to change that method contract. You might have to add like 2 parameters, like pets and treats, to the cat picture API method. And this is just like one example, right? I know there's so many domain-specific examples, but you mark this with add experimental cat pictures API. And what that means when somebody actually tries to use it is it looks like this. So suppose you have this method, and you call get cat pictures there. And what IntelliJ is actually telling you when you use this is this API is experimental, and its usage must be marked with @useExperimental. So if you've used coroutines before, you've probably seen this. But this is like a really, really good thing because it will underline the line red, underline the experimental usage with red line, and this is just like a visual clue telling other developers in that code base, okay, here's something going on, be careful. So you can either fix this error by using @experimental cat pictures API on the do cat picture API stuff method. I know it's a bad method name, which means that this will basically propagate to where do cat picture API stuff is called. So if somebody calls do cat picture API stuff, they will also have to make sure that they mark this usage as experimental. Or if you don't want to propagate this usage further, you can add @useExperimental and then the annotation class. So this tells Kotlin, okay, this is intentional. We are sure that we actually want to use like experimental APIs here. There's also a compiler flag which you actually have to enable to use experimental APIs. So there's a really, really big safety coming towards you if you're using this experimental annotation. All right, so now you've got your like experimental annotation, you've got your experimental APIs all safe. You are there like productive, all right, developer. Let's just stick to developer. Your project manager comes in, hey, could you ship the new SDK version? You're like, sure. And you know in your head, all right, we've deprecated some APIs. But since you haven't learned from before, and I want to showcase the other annotation, let's just pretend you put it in the release notes. You're like, all right, those APIs have been changed, take care, everything, all right, everything will be fine. Your project manager pushes the new version out. All right, yeah, the SDK user takes the new version, is like, okay, cool. Let's see what new features are there. Plugs it into his Gradle build, bumps the version, build error. First thing they see is a build error. And I don't have to tell you, this is like a very, very bad user and very bad developer experience. They plug in the new version, the first thing they see is, hey, you did something wrong. And they will not be totally aware of what's going on. They will have to check in the release notes. Maybe the developer are someone of the kind who just likes to like plug in the new version and tinker around with stuff to see what is going on. And the first thing they see is an error. This is very, very frustrating, and it will, over many, many times of this happening, just drive to lower adoption and having SDK version fragmentation, which is something that you want to avoid. I mean, right? We're at an Android conference, so there is an annotation class for that, luckily. So this is super awesome. This is also part of the Kotlin standard library, and it basically has three important things: the message, what's called replace with, and the level. We'll look at what those mean in a second. So as you see, we're only required to add a message. The other two are optional. So let's do that. Say we have like this legacy cat picture API, and we just deprecate the whole API class because we're totally wild. So we put an @deprecated annotation on top of that and say, all right, this is legacy API. Please use the new cat pictures API instead. That's what we have. That's a replacement. And in code, it looks like this. When somebody's using it, it'll just be marked as strike through, which again is super cool because it's like a kind of fine visual clue saying, hey, something is wrong here. You should be doing something different, but no worries, just like do it at some point. So the other two things about the deprecated annotation are actually even more awesome. So I want to talk about replace with. Replace with itself is an annotation class as well, and it takes two parameters, the expression and the imports. The imports can be empty, and you only have to really specify the expression. So as you see, we have in our @deprecated annotation, please use the new cat pictures API instead. This already is saying, all right, here, this is something else you should use. And replace with allows you to define what should be used instead. So you say, all right, it's cat pictures API, that'll be the new name of the class. And looking at how it actually looks when you use it is, so suppose you're using the legacy cat picture API, and you have this deprecated annotation on top of the legacy cat picture API with the replace with. So IntelliJ will automatically suggest then, all right, replace this with cat pictures API, and you can just like go and hit Alt and Enter, and it just replaces it. For one thing, that might not seem that important, but if you actually have a bigger code base where you're using a lot of, where you have a lot of occurrences of that very specific deprecated method, and you have a replacement for it, IntelliJ can just automatically go fix it. Imagine you have like 40 occurrences, and you just hit like one button. Imagine how happy that developer will be when using that. So this is all really, really awesome. Now, let's take a look at what you can actually do in practice if you, for example, had a typo. We did have this. We were using the wrong term, and at some point we were like, we should probably fix this. So it's basically just a renaming, super simple, but still we had lots of usages and lots of users. So we were like, all right, how do we go about this? We went with an deprecated annotation, saying, all right, we had a typo in here. Please use get random chemical instead, and we specified the replace with annotation. And then we added the new method, right, which did the same. And we just forwarded the old method call to the new method call, which means that we now have a backwards compatible API, which is easily fixable and easily usable. Now, suppose you have great code, like I do. Suppose you have a typo in your class name. You can also do something about this with Kotlin. So suppose you had a class cat pictures API before, and for some reason you now decided, all right, it should be called cat picture API. This is like a project management decision or something, you just have to execute it. So you do that. And of course, by just doing that, you immediately break builds, which leads to bad developer experience. So what you can actually do with Kotlin is define a type alias, forward it to the new class, and deprecate the type alias. Also, then you can offer things like auto migrations with replace with, which is super awesome and really helpful. Now, I really briefly want to talk about class delegation. So, have you heard of class delegation? I was expecting to like see hands. Show me. All right, that's cool. So, if you've used Kotlin on Android before, or if you've used Kotlin before, you might know the lazy function. So you might write, all right, val my repository implementation by lazy, which means that the variable will be computed by lazy. With SDKs, you often have the problem that you have a very complex domain, and that you have lots of components to use. You have just lots of things which are there, which you offer through your SDK that happens as your SDK grows more and more. And this will be your users. They will be like, what? What? So what you can try to do with SDKs is just offer one component, like one thing with which they can work, one thing per like feature, group it where it makes sense. But Kotlin's class delegation allows you to do just that. Maintaining clean code isn't super easy when you try to do that, like if you have multiple components. So let's take a look at what that means. Suppose you have like the interface SDK capabilities, right? You have some stuff in there, and then you have your SDK. You want everything in there, it'll just become super bloated, not maintainable anymore. So you start like splitting up stuff into like canvas capabilities, for example. Your SDK capabilities extend canvas capabilities, and they have that now in there. And now your artboard SDK has to implement that. you start pulling out stuff in what you call like a canvas manager, and then you forward calls to the canvas manager, and it all just becomes super, super bloated, which is not what you want. Even though you don't have like any domain-specific logic in there, it's just a lot of noise in your code, which you can avoid by using this awesome thing. So as you see, we have this interface still, canvas capabilities. And what we say is canvas capabilities by canvas manager. This will automatically delegate this. This will automatically delegate the calls. So basically, this like override fun draw canvas manager.draw, this will be generated by Kotlin automatically, which is super, super awesome and super helpful. So building SDKs in Kotlin, well, building SDKs in general is really, really hard, but Kotlin can actually help you, and you can leverage Kotlin's features to make building SDKs a lot easier for you internally, but also for your users who are using the SDKs. Finally, you can find me on like basically everywhere. I'm mostly active on Twitter. Make sure to follow me on there. I'll be tweeting the link to the slides in a second there. I also have some articles on class delegation up on Medium. Also, the slides will be later on Speaker Deck. And if there are any questions, I think I'm happy to take them. Thank you so much for listening.